Okay, guys, we still have a follow-up exercise, more on our exponential equations. I feel like we need to work on more questions as for the requests that we had. So these are some of the questions that we're going to work as a request that we had. But it's important that we do more of the questions here. They are very nice questions for our revision. All right, question number 1, we are given, just like the previous case, to solve for x. Solve for x, but these are exponents. These are exponential equation. So number 1, you're given 8 to the exponent of x times, this is just like this, just a product here. All right, so this is just a product, and we've got 1 over, that's 4 to the exponent of x minus 1. And this is equal to 1 over 32. All right, so like I said, these are now more complex questions, more complicated ones, the ones that need us to understand the situation of the question. So before you consider the issue of having the same basis, I want us to see something. This is a product. So this here is the same as we've got this as over 1. All right. A as a term can be written as A over 1. 2, a number, can be written also as a fraction as 2 over 1. So meaning to say, even under exponents, this can be written as over 1, so that you can properly see that you can multiply the numerators together. 8 and 1 is going to be 8 to the exponent of x over 1 times 4 to the exponent of x minus 1 is going to be 4 to the exponent of what? X minus 1. And this whole part is equal to what? 1 over 32. Then at this stage, we can consider that idea of the basis now. We can consider that. Remember, I said in simplest form, we are supposed to think of the base. That is the prime number. That is the simplest number that you're going to have between 4 and between 8 and 4. And the smallest number, which is a prime number that you're going to think about there, is the base of 2. Remember, 8 is same as 2 to the exponent of 3. 4 is same as 2 to the exponent of 2. So that means here, in place of this 8 to the exponent of x, we are going to have this in the base of what? 2. That is 2 to the exponent of 3, but being raised to the exponent of what? To the exponent of x. Already there's an exponent that we are given of what? Of x. All right, which is the same thing as this 4 here. In the base of 2, we said 4 is same as what? 2 to the exponent of 2. But already there's an exponent that you are given there. So it's already given to the exponent of what? Of x minus 1. And this is equal to, remember this 1 over 32, we can write it as 32 to the exponent of negative 1. 1 over a number. But in the base of 2, 32 is same as 2 to the exponent of what? Of a 5. Affected by negative 1, so it's same as 2 to the exponent of what? 2 to the exponent of a negative 5. Okay, so the question is, someone is asking, why are we even having this? This is because we have a fraction. And if considering a fraction, we think of the division of the bases that are the same. A to the exponent of m over a to the exponent of n, we subtract our exponents, which is m minus n. So considering that we've got the base of 2 and the base of 2, we have to think along the lines, or you can do the cross multiplication, it's up to you, but consider the subtraction of the bases. But you have a single part here. So you're going to multiply an exponent. Remember, exponent, we multiply. So that's 2 to the exponent of 3 times x, which is going to be 3x. Everything over, we do the same thing. 2 is distributed throughout. So it's 2 to the exponent of 2 times x, which is 2x. 2 times minus 1, which is a minus 2. And this is equal to 2 to the exponent of a negative 5. So that is what you are having there. Now we are back to this concept that I was talking about, dividing the bases that are the same, the base of 2. we subtract our exponent. So it's going to be 2 to the exponent of 3x. We subtract this here, this exponent of what? 2x minus 2. So it's the bracket there to show that you're subtracting everything so that everything can be distributed by the negative. To subtract every term, we subtract 2x. If we subtract minus 2 minus minus, it becomes what? A positive. So that's 2 to the exponent of 3 minus 2x. So 3x minus 2x is going to be what? X. That's 3 minus 2. It's 1x, which is just x plus 2. So these are unlike terms. Remember, x plus 2 cannot be combined. You cannot add that. These are unlike terms. This is what we got from this simplification, this one. We are obtaining this as a single term, 2 to the exponent of what? Of x plus 2. Take note, which is equal to this part, which is 2 to the exponent of negative 5. Once we have this situation, guys, we know that we are done. Why? Because if the bases are the same, I said before, if these bases are the same, it follows that the exponents must be equal. So make sure that you watch the introduction. So x plus 2 must be equal to minus 5. So we can transpose this minus 2 to the other side. X will be equal to minus 2, minus 5 minus 2. So x gives us what? A negative 7. So this is the value of x, which satisfies this equation when x is what? When x is minus 7, it means that if we are to substitute this x being minus 7 here, like this here, 8 to the exponent, remember x is minus 7, so it's going to be minus 7 like this, times, this is 1 over, remember x is minus 7, so it's going to be minus 7 minus 1, which is minus 8, like this. Let's see if we are going to get 1 over 32. If not, then it means this value of x is wrong. Then we have to check our question again. We said 8 to the exponent of a negative 7, like this, times 1 over, so this is, 1 over 4 to the exponent of a negative 8. So this is to the exponent of a negative 8, like this. So this gives us 1 over 32, which is the same as this 1 over 32 that we are seeing. So it means the value of x that we are having there is a correct value. All right, so that is how we are supposed to have this typical question. Well, depends how the question is given, and how you answer those questions is actually the situation of how you are given it. And what can you do? Can you perform the factorization? Is it possible? If not, check for the bases to be the same. Just like this part again, 3 to the exponent of x plus 1 on number 2. All right, this is equal to 9 to the exponent of x times 1 over 27. So if we consider this last part that we have, we got a 3, and we've got this part that can be combined to be in the base of the same, which is the base of 3, which is the simplest number, the prime number. 3 is a prime number. So meaning say here, let us just leave it as it is. Let us just leave it as it is. 3 to the exponent of x plus 1 is equal to 9. In the base of 3 is same as 3 to the exponent of 2. But there's an x that we're having there, so it's going to be 2x. Times, remember we talked about this, 1 over means to the exponent of a negative. But 27 in the base of 3 is 3 to the exponent of 3, which will be multiplied to this negative. So it's going to be a negative 3. So I think on this part, we are now together. We are now in the same part. So instead of performing the factorization, all right, instead of us having the factorization, because no matter if we try to separate, this will be, take note there, what are we having? 3 to the exponent of x. And this is 3 to the exponent of what? Of 2x. 3 to the exponent of 2x. So there's something that we are having there, which is different from all the other part that we had. Okay, I want us to consider this. The moment we see this condition that the other part, it is given as maybe 2 to the exponent of x, Then the other part is now 2 to the exponent of 2x like this. This condition, in most cases, think of formulating what is referred to as a quadratic equation. From which concept? 2 to the exponent of 2x from our laws of exponents can be rewritten in this. Remember, this here simply means a product of 2. So it was 2, there were 2 exponents there. It was 2 to the exponent of 2, which was being raised to the exponent of x, which is the same as 2 to the exponent. We can start with x this time inside of the bracket, and the 2 outside of the bracket. It still means one and the same thing. But as we want to focus on having a quadratic because of this, so we must focus with what gives us a 2, this one, the 2 that is outside, to give us a quadratic expression. In this same 2 to the exponent of x. So how can we achieve it here in terms of what we are given in terms of 3? All right, I want us to separate 3 to the exponent of x in plus 1 here. 3 to the exponent of x plus 1 means we are multiplying 3 to the exponent of x times 3 to the exponent of 1. Okay. Which is equal to 3. Like I said, this part can be written this way or this way. But here we're focusing in the base of 3. So to formulate a quadratic, the 2 must be outside. So I'm going to write this as 3 to the exponent of x being raised to the exponent of 2 so that I properly see the quadratic part of our equation, times 3 to the exponent of what? A negative 3, of which this one, there was even no need for us to simplify this, as you can see. All right, even just leave it like that. Just leave it like that. So this is what we have on this end. Like a quadratic, one of the sides must be equal to 0. So we can transpose this to the other side of the equation so that it gives us a 0. That's 0 is equal to 3 to the exponent of x to the exponent of 2 times 3 to the exponent of minus 3. If we transpose this, it becomes a negative because it was carrying a negative. It was carrying a positive here. So it's going to carry a negative on the other side. 3 to the exponent of x times 3 to the exponent of 1, which is same as what? Which is same as 3. Okay, there's no need for us to simplify. There's no need for us to write as 3 to the exponent of 1. Just leave it like that. So we've got a quadratic equation. Just like in our normal procedure, if we are given x squared like this, what does it mean? It means there is x times x. So if there is 3 to the exponent of x squared like this, what does it mean? It means there is 3 to the exponent of x times 3 to the exponent of x. So we can factor out the 3 to the exponent of x, which is a common term. We can factor out that. Or if you're having a confusion, just write this on the left-hand side. Let us just rewrite it. Do not change anything as it is. 3 to the exponent of x times 3 to the exponent of minus 3. Sorry, this is a squared here. Minus 3 to the exponent of x times 3. I'm just rewriting what is on the right side to the left side, what is on the left side to the right side. So nothing changes the sign there. Most of us, we are used when the equation is written like this. So like I was saying, this here and this here are common. So we can factor out 3 to the exponent of x so that we remain with what? Remember here, there are 2 of them, just like this. So if we factor out 3 to the exponent of x, we divide by 1 of it, 3 to the exponent of x. So if we divide, we remain with what? With 1 of the 3 to the exponent of x. It's because of this squared. So we're going to remain with the 3 to the exponent of x times 3 to the exponent of minus 3. Minus this is common. This is the one that we have here. We factored it out. We remain with what? So we're going to just remain with a 3. So this is equal to 0. Now, if we consider this, we can see this is an inequation. The product of 2 terms to be equal to 0, it means one of these must be equal to what? To 0. One of these must be equal to 0 because we've got a product of 2. 3 to the exponent of x and the bracket. The bracket means everything. It's a single term because of that bracket. So one of these must be equal to 0. So what am I trying to say? 3 to the exponent of x must be equal to 0, or this bracket here must be equal to 0. So you can even write as 3 to the exponent of x times 3 to the exponent of minus 3. If it is equal to 0, it means we're going to transpose this to the other side. It becomes what? A positive. Divide by 3 to the exponent of minus 3. Divide by 3 to the exponent of minus 3. This cancels. When I have 3 to the exponent of x is equal to this as a single term. So there we're just going to use a calculator. That's why I said there was no even need for us to simplify that 1 over 27. We could have just leave it like that. We could just left it the way that it was. So this is 3 divided by, I'm going to have, or let us just put it like a fraction like this, 3 over 3 to the exponent of a negative 3. Let's see what you're going to get there. So if we simplify, because this is a single term, so this is going to give us what? 81. We are now having a single term. So if we check properly, the first part is a single term. 3 to the exponent of x is equal to 0. And this part, 3 to the exponent of x is equal to 81. But now we have to solve for x. Is it possible for us to have a number that we're going to use? I mean, is it possible for us to use these 3 to a certain exponent, then it gives us a 0? It's impossible. There's no way that you're going to take a number 3 or 2 to the exponent of a certain number, then we get a 0. It's impossible. So meaning to say there's no solution here. There's nothing. There's nothing. Okay, let's consider here. 3 is in simplest form. So you're asking yourself, is it possible to write 81 as a number 3 in the base of 3? It's possible. That's 3 to the exponent of 4. So the bases are the same. We are back to that concept again. If the bases are the same, what do? We consider our exponents. X must be equal to what? X must be equal to a 4. So this is the value of x that we are going to obtain. So as we can see, it's a repetition of questions. So we're not going to have all of the questions, like I said. But what I want you to do is to try and do as much questions. I'm just going to end up to number 3. Then if we have got other questions that you still think they are of a challenge, let me know so that we can redo those questions. But I'm just going to end at question number 3 because of our time. But we're going to have other questions. If you say there are still questions that you are still having a challenge, you can have time to do them. All right, let's see. Number 3. 3 to the exponent of x squared plus 2 is equal to 9 times 1 over 27 to the exponent of x. So just like the previous case that we had, we saw that this 3 is in simplest form. So there's nothing that you're going to do, just rewrite as it is. X squared plus 2 is equal to, remember I said this is same as over 1. So it's 9 times 1, which is 9 over 1 times this, which is 27 to the exponent of x. In the base of 3, because we are considering 3 as the simplest number, the prime number. So it's not going to change. But in the base of 3, what is this 9 in the base of 3? It is 3 to the exponent of 2. What about 27? We talked about this. Is 3 to the exponent of what? 3 to the exponent of 3. But there's x already that is multiplying here. So it will be 3 times x, which is what? Which is 3x. So we are in the base of 3. But as we are in the base of 3 like that, which is fine, on the right-hand side, we are still having something that is not yet simplified, this one. We are in the base of 3, which is fine, but there's a term and there's a term they're dividing. Remember what we said. If we are dividing, we can subtract the exponents. So this is going to be 3 to the exponent. We subtract the exponent because the bases are the same. So this is going to be 2 minus 3x. So once we have this condition now, we can equate because the bases are the same. So it means x squared plus 2. X squared plus 2 must be equal to this part that we are having, which is 2 minus 3x on our exponent. We have formulated an equation that we are supposed to solve for x. That's it, a quadratic equation. And like I said, for a quadratic equation, one of the sides must be equal to 0, meaning to say we have to transpose these terms. X squared, we transpose negative 3x this side, it becomes what? It becomes a positive. We transpose 2 this side, it becomes a negative. 2 minus 2, that's what? That's a 0. So meaning to say we are left with nothing. We're just left with what? x squared plus 3x, which is equal to 0. X and x is common. So we're going to factor out x from our factorization. X squared divided to x, what we obtain? This is x plus x, and x cancels. We remain with what? We remain with the 3. So this is going to be x plus 3 is equal to 0. All right. One of these brackets from the 0 concept, like I said, must be equal to 0. So it's either x must be equal to 0 or the bracket of x plus 3 must be equal to 0. That is the concept. So already here we've got a solution that x is a 0. What about here? Transpose negative 3 to the other, positive 3 to the other side of the equation. It becomes what? A negative. That's 0 minus 3, which is what? A negative 3. So we've got the value of x here and also the value of x. If x is equal to 0, are we going to have this solution that we are, are we going to have what is on the other side? So you're supposed to also test your values, but that is the condition just for solving values of x. Like I said, guys, we have worked with much questions. We're going to see more questions in our next class. If you still have challenge on these questions that are remaining that I did not attempt, let me know, but it's a similar condition. So I want you also to check and prove and test your answers and see which is the exact answer. Then let us talk about it on the comment section. Let us try to work on it together as a family. But for now, that's it, guys, from Mason African Motives. Till we meet again.